The Cauvery Delta is located at the mouth of the 80,000 square kilometer Cauvery River basin. Cauvery River, which has its origins in the high elevation, biodiversity-rich Western Ghats, flows through a semi-arid hot plateau before reaching the delta, an area of nearly 7,500 square kilometer, which is slightly wetter. While the upstream areas get rainfall from the southwest monsoon between June and September, the delta gets most of its rainfall from the northeast monsoon from October to December via intense cyclonic storms. The canal irrigation system in the delta began with the construction of the Grand Anicut by the Chola king at the mouth of the delta. It remains one of the oldest water regulation structures in the world still in use. Canal irrigation allowed a system of intensive paddy cultivation, often 3 harvests, along with a collapsing system of traditional water harvesting tank structures. Today, the Cauvery Delta is under increasing human and natural pressure. The Cauvery Delta had been in history depending on surface water flows for the past more than 2000 years. In the last 2 decades, the flow of river water into the Cauvery Delta has reduced. Since the 1990s, groundwater extraction has drastically increased. Currently, the wells are at 500 to 600 feet, and if we go on pumping as we are today, the delta itself will start getting compressed and land subsidence and much more seawater intrusion. Groundwater has not historically been part of the Cauvery Delta, so there is not much of history to build on. Most farmers' associations are connected with canals or tanks, and understanding of groundwater is not as much. The perception of farmers in the delta is that the northeast monsoon is like a demon which cannot be harnessed. But in fact, the Cauvery Delta gets around 1250 mm of rain, albeit in very few days of heavy rain. So, can we harvest this rain to sustain the groundwater table? The soil in the delta is sandy and therefore very permeable. An obvious solution, therefore, is to restore the capacity of the tanks by maintaining them properly, harvest more rain, and improve groundwater recharge. The traditional old delta has a few tanks, but the new delta was dependent on tanks historically. Today, most of the tanks in the delta are in disarray, covered with precipitous trees. They are also silted up. A key component of the solution will be to find a decent use for the silt and woody biomass to cover some of the costs of restoration. We need a campaign to change this. We need to start getting the communities to say, how do we look at groundwater assets? Where can we capture water and rainwater harvesting? The 3 components of the campaign we propose are: first, the campaign has to be about this change in mindset and changing the farmer organizations to be around groundwater. The main message will be explaining to farmers that we have become more groundwater dependent. Now, if we continue like this, the future will be bad. But we need to do things differently because all the organizational thinking is around surface water. Students can help organize workshops and help people understand groundwater and mapping. Second, a citizen science campaign to collectively understand the groundwater situation, how the wells have changed over time, their history and salinity. Then, we can bring the science and show the community numbers around how much can be actually put into the ground, how much they can harvest, and what will save the groundwater. Student groups can be part of the monitoring as part of college projects. We will teach them to use salinity and groundwater depth measurements and collect data through ODK. Third, then we can start organizing around rejuvenation. We help communities organize and raise resources based on the science to actually rejuvenate and monitor the local tanks. We will engage local youth groups to organize rejuvenation activities. Awareness, monitoring, rejuvenation.